Hello everyone, welcome to our part 2 of our discussion of chapter 5. This is more the demonstration of how this works in Excel or using our present value tables that were introduced in part 1. So remember, we talked about the idea that amount today is not equal to an amount 3 years from now. And the difference is interest. And the calculation of that can be done using a formula. So first of all, if you were to look at from a future value standpoint, if you had 5,000 a day and you put it in to earn interest and you're earning 10%, you would then, to calculate that, you take 5,000 times 1.1, remember 1 plus the interest rate, and you get 5,500. Then you take the 5,500, multiply it by 1.1, get 6,050, multiply that by 1.1 and get 6,655. And if we were to do what's called the future value formula in Excel, we'd come to the same amount. That's what it's doing. It is a shortcut to do this whole process. Now, we're usually in accounting going the other way. We know that we're going to have a $10,000 cash flow because of this machine. We paid for it now, that we know what that amount is, but it's going to bring us in a future cash flow 3 years from now of $10,000. All right, and the interest rate that we would be giving up by buying the machine is 8%. So the long way would be to take the 10,000, divide by 1.08, get 92.59, divide that by 1.08. Remember, 1 plus the interest rate, get 85.73, divide that by 1.08. And we're kind of rounding here, and we get 79.38. Now, the shortcut using the table is to go to 8%, and how many years we work on? 3 years, right? So there's 3 years, the 3-year row, and the 8% column, 0.79383. So we take the 10,000 that we're going to get in the future times that 0.798383. That gives us the same result as if we had done this 3 different times. So that's what we're doing here, is we're doing the shortcut of present value. And just a couple of other examples. 10,000, okay, 3 years from now, this time with 11%, we go all the way over to 11%, we get 0.73119 on the table. Multiply that by the 10,000, and we get 7312. So 7312 today is equal to 10,000 3 years from now. And so if you had 7312 today, you would earned 11% per year, you would get 10,000 3 years from now. And then same thing with 6%, again going to the 6% column and the 3 years, and we get the 0.83962. Multiply that by the 10,000 and we get 8396. Here's the problem. We can do lots of different combinations, lots of different dollar amounts, and use this table. And if the payment is 4 years from now, we use a different row. If it's 5 years from now, we use the next row down, and so forth. And we can do a whole bunch of payments and then add them up and get the present value. However, what we are limited with the table is we only have so many columns. So if the interest rate is 5.5, we're stuck a little bit in that we'll have to do an estimate between 5% column and 6% column. All right? And just because you can make a lot of mistakes looking things up on this table, as helpful as it is, it's a lot of numbers, and you can get off by one row or one column, transpose numbers, and then you're going to have the wrong answer, hopefully not by a whole lot. So Excel is a great tool to help us do this more easily. So this is an example of what a problem like you would need to do for your homework. and in real life for a NPV, or net present value, IRR scenario. And we'll do it with the table, and we'll do it with Excel, and we'll see the difference. So here's the kind of information we need. We need to know what this equipment costs right now, additional working capital that is going to be needed, additional inventory or receivables that's going to be necessary to make it run, okay? And then we're going to need, in this case, $50,000 of repairs in year 4, significant upgrade to make it continue to last in total 6 years. At the end, then we will sell it for $75 and get back our working capital. So that's the information we know about the actual investment of the equipment. This equipment is going to result in us being able to make more of our product. And so that's going to increase our revenue by each of these amounts for each of these years. And again, these are estimates. That's why they're nice and rounded. On top of that, we're going to save on materials because we're going to have less waste. And so over the course of the year, those years, we're going to save this much money. So we're going to get in more revenue. We're going to save money. Those are cash flows. But we have to maintain this equipment at a cost of $3,500 that we wouldn't have if we hadn't bought the equipment. So you can see the total cash flow is positive $86,500, $99,000, $102,000, $44,000 in the year that we have to pay the extra $50,000, $91,000, and then last year, because we get some of it, we sell it, it's up to $187,500. So those are future cash flows. They clearly are more than what we're paying out for the investment now, but we know that they need to be adjusted. We need to take the present value of those. So one way we can do that is to go to the table. We go to the 7%. That's the required rate of return that is given to us. 7% column. And the payment, the cash flow for year 1, we're going to go to year 1 row. And the cash flow for year 2, we're going to go to the year 2 row. And 3 row, and 4, and 5, and 6, all the way down. Each of those factors are going to go right here, and then we can simply take the amount of cash flow, multiply that, and that's what we have for the present value of each of those cash flows. Add those up, and then compare it to the investment that we had to make. And we get $14,454 on the negative side, which would mean that we don't go ahead with this project. It has a negative NPV because these are not as much as how much you're paying out. Now, the shortcut using the formula I showed you in the part 1, we would put NPV, whoops, you see the formula up here in the equals NPV 0.07, that's the required rate of return. You can put 7%. Excel's smart enough to know either one of those. Highlighting the cash flows in blue, future cash flows, and then because I put this in as a negative, we add the amount there. That compares it, and we get the same. You can see there's just a little rounding error because all of these factors you see on the present value table are rounded, and it is really close to what we get if we do it, you might say, the multi-step way. To do internal rate of return, you IRR formula, and then you highlight all of these cash flows. For this to work, the first cash flow, the first one that you highlight, needs to be the negative amount that you're going to pay out at the start of the project. to install this asset. So it needs to be a negative number. If you put a positive number, if it's done as a positive number, Excel will give you an error. It needs to be negative, and then the rest of them can be positive. And it will tell you that this project is going to make 6%. Our required rate of return is 7%, so we wouldn't do it. It doesn't make enough to meet our required rate of return criteria, or our hurdle rate criteria, or cover the cost of capital, whichever terminology you like to use.